Hi, and welcome back to another video in our series on covering statistics for year one. So this will be one of the first topics that you'll learn in statistics when you study the subject. And what this topic will be data collection. So there aren't actually very many calculations you have to do in this topic, but it's quite important that you understand some of the theory behind it because a lot of this theory is the reason for a lot of what you do in statistics. So if you understand this chapter really well, it will really help you understand, why do we use statistics and what's the importance of it. So in this chapter, we'll be looking at some stuff like getting data from a population and a couple of definitions of different kinds of words that you might see every now and then. We'll look at different ways you can sample a sample from a population. So there's a few different types of those, and we'll take a look at that. And we'll also look at different types of data. So that will be stuff like continuous data, discrete data, and so on. And we'll also take a look at some kinds of questions that might come up for this. So what I really want you to understand from this chapter, some of our key takeaways are understanding what is a population, what is a sample, what is a census, as well as the advantages and the disadvantages of both. Normally in exams, they'll probably ask you, what does it make more sense to do and why should you do it and why you shouldn't. We'll look at what is random sampling, systematic sampling, stratified, quota, and opportunity sampling. And finally, we'll look at the different types of data, so qualitative, quantitative, discrete, and continuous types of data. And finally, we'll look at how this all fits together when we group the data up. So without further ado, let's carry on to one of the first areas that we should look at for this topic. So starting off with statistics, like we said before, we want to understand what is a population, what is a census, and what is a sample. So let's have a question. Let's pose a question here. So let's say we have a question of some kind. Our question might be, what is the most popular TV channel in the UK? So what is the most popular TV channel in the UK? Now, there are lots of different ways we could do this. So one of the ways we could do it is ask every single person in the UK, or we could ask like a few people, and if we've asked enough people, we might think, okay, that's enough to kind of get an accurate answer. If we want an answer which is 100% correct, we know for 100% sure we've got it right, then we'd have to ask every single person that we're interested in the UK. And of course, this is not really feasible. So statistics kind of looks at the fact that normally we have a huge amount of people, or like a big kind of data set that we have to ask. But in real life, we can't really, go around and check every single data point. So statistics kind of just looks at how do we look at like a few of these data points and kind of guess something about the population that we're trying to do. So I mentioned the word population a few times. What do I actually mean by the word population? So a population, quite simply put, is basically the entire set of items that we're looking at that we're interested in. So if I had to write that, the entire set of items we are interested in. And what I mean by that is, for example, in this question, when I said the most popular TV channel in the UK, in real life, I probably wouldn't ask, kids who are under 3 or kids under 4, because probably a lot of these won't really have a favorite TV show. Or more accurate, let's say the kid is at less than 1, he won't really have a favorite TV show, be able to say it. So I probably wouldn't ask those types. So when I say this part here, which is we are interested in, I mean all the people who would be qualified to answer our statement. So in the most popular TV channel, probably kids who are 5 and upwards. So the population is every single person that we're interested in. So the population in this case would be the entire UK population who is older than 5. So that's what population is, every single person that we're interested in, or the entire set of items we're interested in. Now, continuing from this, if we have a census, and you might have heard of the UK census, what happens in the census is you actually end up asking every single person within a population. So in a census, you measure every single person, or every member, or every item in a population. So like we said, a population was the entire set of items we're interested in, and how can we, gather data about it? So before we said, well, we have a few different options. So let's say that, actually we'll continue this example. Before I get onto that, I should probably explain what a sample is. So yeah, a census is you look at every single person in the population. Now let's look at what is a sample. So as you can probably guess from what the word of a sample means, is when you take, a few observations from a subset of the population, which means I can't look at everything about the population, but a sample is when I take a subset of the population, and from this subset of the population, I want to understand some more information about the population in its entirety. So a subset of the population gives me information about the whole population. So about the whole population here. So this is a bit more practical because often I can't, ask every single person. So now just kind of put this together and just kind of help you understand it better. So if I had, let's say I had an entire set of people. Let's say this was my entire population here. Let's say this is my population. And let's say in my population, these crosses represent all of the people in my population. This is just an example. So let's draw a couple of crosses. So as you can see, there's a lot of people that are asking. And just imagine there's a lot more. So let's actually draw in a few more here. Let's copy that and paste that across. So here we go. These are all the people in our population. Now, what would happen in a census is what you'd end up seeing is that we would actually ask every single person in this population. So if the blue highlighting represents all the people we'll ask, when it comes to a census, what ends up happening is we'll ask every single person. And if you don't ask every single person, it's not a census. So that means that we've done a census. And a sample, if this is also my population, means I might ask a few people. So I might ask these people, I might ask these people, I might ask these people, could ask this person here, a few different people across my sample. But the idea of my sample is I don't ask everyone, but I ask enough people so that I'm happy that I'm roughly, fairly accurate in what I'm doing. So that's kind of how you can look at what a census is and what a sample is with regards to your population. So obviously we've talked a bit about the advantages and the disadvantages of both of these approaches. And it might be obvious to some people which one they'd use over the other, but it really does depend on what you're trying to find out about the data. So now what we'll do is we'll move on to some of the advantages and disadvantages of using a census over a... So now if we look at a census first. So let's just take a look at a census first. What are the advantages of a census? So one of the main plus points of a census is that it will give you a 100% accurate result. If you've asked every single person in your population a question that you're trying to find out, then of course if you ask every single person in that population the same question, then you're going to have an accurate answer. But then there are quite a few disadvantages. One of the things is the time taken. It takes a very long time to do a census. Imagine doing this for the whole UK and asking a question. Often in statistics, your population can become very, very large. So a census can become a little bit impractical. You can't also do this when, let's say you're trying to test something. So when you're trying to figure out something, so let's say what is, I don't know, if I was selling 2 bars of chocolate and I wanted to figure out which one people prefer, if I had to give every single person in my population 2 bars of chocolate, then I can't really do that because I can't give 1 million bars of chocolate away. So if the testing process that I have destroys the item, then you can't use it. So you can't use it then because you can't, if you're destroying the item, you can't keep getting the item back to give to other people. And the other thing is there's a lot of data to process. And if you imagine there's a big amount of data, you need to do a lot of number crunching, and that's not always the easiest task. So there's a lot of data processing involved. Data processed. Cool. So that's some of the advantages and disadvantages of a census. Now if you move down to a sample, with a sample, things are a bit better, as you can imagine. So one of the main advantages of the sample is that it's less time consuming, so it takes up less time. And also it's less expensive. So less time, less expensive, and that makes it a little bit more practical to do. And then, you have to get fewer responses. Fewer responses are needed. Because let's say I asked 100 people and I only got like 50 back, then sometimes that's okay too. And of course, you have less data to process. So a lot of the plus points for the sample are the negative points of the census, if just reversed. So you have less data to process. So apart from that kind of stuff, what are some of the disadvantages of a sample? So one of the disadvantages is the final answer that you get, or the final conclusion, let's call it. Conclusion is less accurate. Of course, if I've only asked half of the population, or let's say if I had to do the question I had before and only asked 100 people, it really does depend on which 100 people I picked, and that can really change the answer I get at the end. So it's not always as accurate as a census. And the other thing is that the sample I pick might be too small. So the sample picked might be too small. And why is this a problem? One of the main reasons that this could be a problem is because if I've taken a sample, it might not really give me enough information about my population, or it might give me like the wrong impression of my population. So an example for this is, let's say I picked 100 people to answer a question. Let's say I asked a bunch of 10-year-olds, I asked 100 10-year-olds. It's quite likely that the 10-year-olds will give me an answer which is probably relating to a cartoon that they've seen or something like that. So if I just use that as my sample, then that's not really that representative of my whole population. So in statistics, when we're doing samples, we have to be really, really careful that we pick the right kind of sample. And doing this is not as straightforward as it might seem. So moving on from this, let's just talk a little bit more about, how the sample can affect the conclusions we've made. So how does picking a sample affect our conclusion? So that's the kind of question that we want to answer right now. So how does picking a sample affect a conclusion? Well, one of the main things that we care about is we care about the size of the sample. Obviously, the more people you can ask, the better it is. However, let's say there's a bigger size is more accurate usually. However, it needs more resources. So it would be nice to have a bigger sample size, but we can't necessarily always get this bigger sample size. So usually the bigger the sample, the more accurate it is, but you need more resources to be able to cover it. And also usually if your population is quite different, so if we asked this question when we were doing the TV shows, then if the population has also different segments, then you need a larger sample to kind of capture these different segments. And what I mean by that is, let's say these different colors I'm going to draw, like this, these are probably all the green kind of crosses. These are all of my 5 to 10-year-olds, and all the black crosses are going to be my 10 to 15-year-olds. And just for the sake of an example, let's have some orange crosses that have also got my population, and these can be my 15 to 20-year-olds. So now what I need to be really careful is that if I pick a sample, I might end up picking a sample such as the one over here. So I might end up picking this sample. If I happen to pick the sample from this whole population that I've got, then that's not going to give me the accurate result. Likewise, if I also pick something like this, it'd be a bit more accurate, but it still wouldn't be very accurate. If I was picking a sample from this, I'd probably want something a bit more like such. It's a bit messy, but you can get the idea. I want something which can incorporate, roughly the same patterns I find in my big population in my small sample. So obviously you can see why something like this is bad, something like this is bad, or something just like that is bad. So it really just depends on the kind of sample you pick, and it's very important. If my population was uniform, and what I mean by that is, let's say my population looked a little bit like this. So I knew that in my population, I had some sort of pattern like this. Then it's a lot easier for me to pick a sample, because I'm like, okay, cool, I can pick this as a sample because that represents my population, that represents my population, so does that. So because uniform, I know what the patterns to expect. However, if it's not uniform at the very like the above case, then it's a lot more difficult for me to select a population. And like we said before, the different samples that you pick can end up with different conclusions that you make, and that's just because you have different kinds of things that you pick up in your sample. So like we said before, if I picked up all these 5 to 10-year-olds, I have a different answer to, let's say, if I picked up all of these 15 to 20-year-olds in my sample. So it's very important to get the sample correct. And just some technical terms that you should be aware of. So when you're doing something like this, the individual units that we've got in here, so if I just get rid of that, the individual units that we have in here, these crosses, every single person in this thing is known as a sampling unit. So every single cross that you can see here, every single one is a sampling unit. And usually the sampling units in your population, you'll often number it. So let's say, what I mean by that is, let's actually use this bottom one here instead of the top one. If I was using this as my sample, then normally what you'd want to do in statistics is you would want to number your sampling units as so. So here I might number them from 1 to 12, and all of these things put together are known as my sampling frame. So just to recap that, in my population, every individual cross that I've got, every single individual unit here, all of these are known as sampling units. And normally in a sampling frame, when I numbered them and made a list of everything all put together, this is all known as a sampling frame. So that kind of covers some of the basics of, statistics when it comes to a population and when it comes to taking a sample. So we talked a lot about sampling, and what would be good to cover next is what different approaches do we have to actually undertake sampling. So we'll just cover some of this in the next. So since we've been talking a lot about sampling, let's talk about some of the different ways in which we can actually achieve this. So we're going to take a look at three different things. We're going to be taking a look at simple, random sampling, systematic sampling, and stratified sampling. So normally when we're selecting a sample, it's quite important that we choose it so it's representative of our population. If you're trying to find out your favorite TV show and you go ask all of your friends, then it's quite unlikely you're going to get a fair representation because all of your friends might like the same show, and then you're not including people who might be older and have different tastes. So it's quite important that when you're sampling, it's as close to your population as you can get, and hence you want it to be representative. So simple random sampling is one of the methods in which we're going to take a look at first. And before that, what I should also mention is that normally the random sampling, any of these types of sampling we're talking about, it helps to remove bias from your example, and this is quite important as well. So let's take a look at what simple random sampling is. So simple random sampling. So what is this? So this is normally where you want to select, let's say you have a population, or let's say you have a sampling frame, and you need to select a bunch of people from that sample. Then what happens is you say that every single person in your frame has an equal chance of being selected. So it'll make more sense with an example. Let's say I have 1,000 people in my school, and I need to find out what the favorite TV show of all these people are, going back to the TV example. So in simple random sampling, what you would often do is first you have to allocate a sampling frame. So let's say in this case it's 1,000, and so list of 1,000 people. And I've got all of that in my register from my school. Now what I might do is, let's say I've got someone called Sophie, Bob, Adam, and so on. What you'd normally do for this is you'd normally number them from 1, 2, 3, and so on. And then what we have to do is to make sure we're randomly selecting numbers, we use a calculator. And on this, you have a simple random generating function, which generates you random numbers. And you can use this to generate random numbers. And based on the numbers that you found, you can select that person. So let's say I use my calculator and I've got the number 3, then I would select Adam. And then let's say I did it again and I found the number 1, I would select Sophie. And you keep doing this until you found the sample size that you want. So let's say my sample size was 10. Then what I would do is I'd find 10 random numbers on my calculator, match the numbers on my register, and then that would give me my random sample. So this way is removing any bias because you're purely basing on the numbers that you've got, and it can be quite a good way for you to select your sample. Another thing is that you can also use something called lottery sampling, and this is very similar to what we've just done. In lottery sampling, what you might often do is you might write the names of the people on tickets and literally draw them out of a hat. And that can also be random if you want to get a random sample. So simple random sampling is pretty much just that. It's in the name, it's pretty simple, and that's how you do it. So another way in which you could do it, which is a different type of sampling we'll take a look at, is something known as systematic sampling. So systematic sampling. So what is systematic sampling? Well, the thing is about a random sample, we might also end up selecting like a bunch of 10 people in our sample from before, and they might not actually be the best representation of our group. With random sampling, you're not always going to get the best sample that you always want. Sometimes it might be great, sometimes it might not be so great. And that's just the thing about having a random sample. You never know what's going to happen. So another way you can do it, just to be a bit more careful, is do something called systematic sampling. And what you do here is, if we have our list again of people from 1 to 1,000, instead of just randomly choosing people from it and using the calculator, what we do instead is we choose people at regular intervals. So what do I mean by that? Let's say I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and let's say I keep going. Let's say I've got about 10 people in my new sampling frame, and I want to do systematic sampling. So what I might say for my systematic sample is that I'm going to choose a regular interval, and at every second person, I'm going to pick them. So in systematic sampling, I'll skip the first one. Or actually, no, it depends how you normally do it. Sometimes you might start from the beginning and then take it on from there. So I'd say I select the first person, then I select the third person, then the fifth person, seventh person, and so on. Or if I chose to start with the second person, I might have chosen the second, then the fourth, then the sixth, then the eighth, and so on. But the key thing is, you're always choosing the people that you want at regular intervals. And that's what makes it systematic when you're going through it. So that's the part where you've got systematic. You saw that at the beginning of deciding where I should start. The best way to start in systematic sampling is actually to choose a random number. So again, you can choose your random number in a calculator, and actually you can use that to start. So let's say on my calculator, I chose a number between 1 and 10, and I got the number 8. So then what I would do then is I'd start at the number 8, skip 1, go to 10, skip this number here 1, go to number 2, then skip 3, go to 4, go to 6. So that's another way it kind of wraps around. So you can also do systematic sampling like that. And the interval you choose will often depend on the question. It should tell you that, or you have to choose it yourself. But that is more or less what systematic sampling is. So that leaves us with the final type of sampling, and this will be stratified sampling. So what happens in stratified sampling? Let's go down here. So we've got stratified sampling, which looks like this. So in stratified sampling, what happens is we take our population and then we try to divide this into mutually exclusive strata. And the word strata is probably something new. So what this means is, for example, if we have a population of people, we might decide to split them into males and females, or we might decide to split them into people from 0 to 10 to 11 to 20, 21 to 30, and so on. So it's kind of taking your population, splitting it into groups that covers everything. So another example might be, if I want to find out, what's the most popular hair color, I might take my population and I might break it into people who have blonde hair, black hair, brown hair, and so on. As long as I've covered all the different types, that's what different strata are. And then what we do, once we've got a different strata, we take a random sample from each of these strata. So this kind of example will make more sense once we kind of draw it out. So let's say that we have a population. So let's say we have a whole population here. And in my population, I want to find out the favorite movie that people have. And I want to make it fair. If I ask just exclusively kids, then I might get, like a Disney film or something which is aimed for kids. And if I ask older people, then I'll get a different answer. And if I want to find out on average what's the most, popular TV show, I should be asking everyone. So what we do here is we take our population and we break it down into different strata. So what we might break it down into, if we were doing strata over here, is we might break it from 0 to 10-year-olds, 11 to 20-year-olds, 20 to 21 to 30-year-olds, 31 to 40, and let's say 41 plus. So this would be the different strata that we have. So once we've got the strata, we will have to take a random sample from each of them. So what will happen here is we might say, okay, once you split it into these different people, I am going to select 10 people from here, 10 from here, 10 from here, 10 from here, and 10 from here. So this is how I can get a sample size of 50. So this is more fair because what we're doing is we're making sure that we're selecting people who are across the board representing our population. So this way we don't need to worry about not representing our population that well. So you can see there's lots of different ways that we've learned about representing our population. So what we've said is we've had simple random sampling, which is because we want to make sure we've represented everyone, we just randomly pick numbers and then hope that's a good representation. We've had systematic sampling, which once we take a starting point. We might go once every 5 people, once every 10 people, but we're hoping that will cover most of the people in the population, give a fair sample. Then we've got stratified sampling, which is probably the most advanced of the three, which is trying to say that, okay, we've got a population, break it down into the different sets we think are good, and select people from there. So there's also an equation which will be worth knowing for stratified sampling, which I'll put up here. So the number that you sample in your stratum, so the number sampled in stratum is equal to the number in your stratum divided by the number in population. And then you take all of this and you times all of that by the sample size. So this will make more sense if we perhaps look at an example specifically for stratified sampling. So let's say that I'm working in a bakery and I've got a bakery which has got a really big event coming up, and therefore I look at the different ages of people I've got. So let's say I've got a bunch of 0 to, or in the case of this 0 to 20-year-olds working, I've got some 21 to 40-year-olds working, and I have some 41 to 60-year-olds working. So what would happen in this case is, let's say I've got 50 0 to 20-year-olds, I've got about 20 21 to 40-year-olds, and I've got about 30 41 to 60-year-olds. So if you remember what our equation before was, we said it was the number sampled in stratum was equal to the number in stratum over the number in our population, and we times that by the population size, like this. So in this case, what would happen is, let's say we've got all of these workers and we want to sample from all the 100 people, we only actually want to sample 10 people. So we don't want to sample everyone, we only want to sample 10 people. Now the thing is, unlike the example we had before, we could see that our stratum was split all equally. So you can see that you've got 10 people here, 10 here, 10 here, 10 here, and 10 here. So this is all equal and it's spread across. But sometimes it might not be the case that you want to argue that you want it to be completely equal across the strata. Because what if my population has a lot of 21 to, let's say, it has a lot of 21 to 40-year-olds. So this section of society, if that is the one that's, got the largest number of people, then maybe I should have chosen different numbers in my strata. Maybe I should have chosen 5 here, 5 here, 15 here, 15 here, and then 10 here. Maybe that would have been more fair. So this equation kind of helps us get around that. So like we said before, we wanted a sample size of 10. And we've got 100 people to choose from. Now, obviously, you can see here, like the example before, the most representative part of our population, there's mostly 0 to 20-year-olds. Then there are 41 6-year-olds, and the least are the 21 to 40-year-olds. So we want to represent this in our stratum when we're doing this. So how can we do this? So for 0 to 20-year-olds, if we use the example that we've got, first we need to take a look at how many workers there are. So there are 50 workers in our 0 to 20-year-old category. We divide, so that's the number in sample. Then, the number in our stratum. And then after that, we need to divide this by the number in our population, which is 100 people. And then we multiply that by the overall sample size that we have. So the overall sample size that we wanted, we said was 10. So multiply by 10. So if we do that, we get a half times 10. So that means we should be choosing 5 people from this sample over here. So if we do the same thing for the 21 to 40-year-olds, we find there are 20 out of 100. We times this by 10, and this will give us 1 over 5. So that will give us 10 over 5, which is 2 people. And if we do this for the 41 to 60-year-olds, what we find is that we have 30 over 100. Multiply that by 10. So that gives us 3 over 10. So that will give us 3 people. So like you can see, if we add up all these different numbers, we have a total sample size of 10. And this is also representative of our original population, because we've got 5 people, which represents the 0 to 20-year-olds, 2 representing the 21 to 40, and 3 for the 41 to 6-year-olds. So it's in the right kind of proportions. So that's kind of how you can do stratified sampling. you look at the number you put in your sample. So this top part, where does that come from? You get this top part from here, the number in your sample. Where does your population number come from? Well, to get your population number, you have to add up all of the different people that you've got. So 50 plus 20 plus 30 give me 100. And where do I get my population size from? Well, I get that from my sample size of 10 that I've decided. So the question will usually give you all of that, and you just have to put it into that formula. And the final answer you get will be these, which tell you how many you should pick in your sample. So this means that if I have 5 people I need to select, I should choose 5 people from the 50. Then when I've got 20 people, I should select 2 people from there. And when I've got 30 people, I should select 3 people from there. So that's how that part works. So we've taken a look at a lot of the different types of sampling that there are, and now would be a good time to summarize a lot of the different advantages and disadvantages of each of them. So starting off with simple random sampling, some of the good things about this one is that it's going to be bias-free. So because you're choosing everything randomly, you're not choosing with any preconceived things in your mind. So you are just going to be making sure that everything you pick is purely random, and this will make it bias-free. It's also quite cheap and simple for small populations and samples. So if you have a small population, implementing simple random sampling isn't a very long process, and it can be quite cheap, which in the practical world is quite a useful thing to have. The other thing that you also have is an equal chance of selection for every single sampling unit. So every single member of your population will have a fair chance, or I should say an equal chance of being picked, which is often a good thing when you're doing your sampling. But there are some problems, and these include the fact that when you have a large sample, then simple random sampling can become quite difficult to do. And also you need to actually make a sampling frame to pick from. So if I was saying that I'm going to do simple random sampling for the favorite TV show of everyone in the UK, well, then I need to pick maybe like 100 people from which I'll randomly sample. And if the population is big, like we said before, this could be a problem. So then moving on to systematic sampling, we can see that systematic sampling is also quite easy and quick to implement. And the good thing is with systematic sampling is that it can still deal with large samples and populations pretty well. And the reason for this is you can just have a huge step in between the different picks that you make. So you might want to go every 100 people, every 1,000 people, or whatever number you choose, but it helps you deal with the larger samples and get through them more quickly. You still do need a sampling frame for this one, and sometimes if your sampling frame isn't actually randomly picked, then you will have some bias introduced here as well. So finally, we'll take a look at stratified sampling. So with stratified sampling, it's quite good because it reflects your population better. And that's because we broke down our population into separate groups. And this means that we represent our population quite proportionally, which is quite a good thing to have in this kind of sampling. But then one of the difficult things with this is that you actually need to figure out what your strata should be. So it's not as easy as just breaking down the groups or your population into small groups. But someone actually has to sit there and say, okay, what are the right groups for me to split my population into? And this is actually quite a challenging task to do. And also the selection within the strata themselves will also have the same drawbacks as you did with systematic random sampling. So overall, these are the 3 different methods that you have. And what's important to keep in mind is that for your exam, you'll often be asked what is an advantage or disadvantage of each, and this list will be a handy thing to keep in mind. So now let's take a look at some examples of non-random sampling. And the first example we'll take a look at for this one will be something known as quota sampling. So what exactly is quota sampling? So quota sampling is where the person who's conducting the sampling, he'll often choose some characteristics about a population that he thinks will represent it. So for example, let's say you're going for a job interview, and in that job interview, the person decides, well, I'm going to have at least 50 people who I accept will have to have a degree, and the other 50 people who I accept have to have no degrees. So when the people will come into my interview, first thing I'll take a look at is I'll take a look at who I'm going to see, and I'll assess what group they fall under. So the first person comes in, and then I ask them the question, do you have a degree? If they have a degree, then I will say that, okay, the person will then fall into my sample space for people who have degrees. So I look a bit something like this. I have 2 sets of quotas, and my quota is I need 50 people who have degrees. I need 50 people who have no degrees. That's the quota that I want to fill. So as the people come in, as these are my people, I'll take a look at the first one and say, okay, you have a degree, so you fit into this quota. The second one may also have a degree, so he will also fit into this quota. The third person may not have a degree, so he'll fit into this, and so on. So as you basically go through each of these people, you want to be sorting them out into different groups, and you'll basically decide whether you think this person will fall into the right quota or not. Eventually, what I might find is that as I keep filling up my different quotas, I might eventually fill up all 50 spaces for the people degrees. So that means the next guy who comes along, let's say there's someone who came along here, he might also fit into the degree category. But when he takes a look at that, there's actually no space for him to go because my quota is full. So then, therefore, he'll be rejected. So the thing with non-random sampling is, or especially with quota sampling, is you have a quota and you say, I have this many spaces that I need to fill for a certain amount. And as you start interviewing people, or as you start taking a look at your the people in your sample, then you'll keep trying to fill up your quota until it's filled up. Now, once it's completely filled up, if you find someone who belongs in our quota, we'll just simply ignore them and move on to the next person. And you'll normally want to carry this on until all your quotas are filled. So then eventually the situation would look something like this. And then we filled up everything. So just to summarize what this would look like. So let's say that I have 4 different quota that I need to fill like this. And as I have people come along, I find that this one can fit about 10 people, this can fit 5, this can fit 5, and this can fit 2 people. So these are the different quotas that I've chosen, and this depends on the researcher. So as I'm going through this, I might find that I've filled a few people here. The next person I meet might go here, some people might go here. Then eventually what will happen is as you add more and more people, you'll eventually start to fill up. So as you can see here now, if I have 2 more people here, and 2 more people here, and 1 more here, now I've filled up all my quotas. So even if I have people who do belong in these quotas, once they're filled up, I can no longer fill these quotas, and the only space left of the people is 10. And this will also continue all the way until I filled up my 10. And once that's done, I finish on my quota sampling. So in quota sampling, you can see you have a bunch of quotas you need to fill. Once you fill those up, then you're completely finished. So that's how quota sampling works. And this leaves us with something known as opportunity sampling. So this is our second form of non-random sampling. So opportunity sampling. So what is this? So opportunity sampling is quite simple. Opportunity sampling is quite simply where we're going to take a sample from the people who are available at the time that we're trying to conduct our interviews or the study that we're trying to do, and they fit the criteria we're looking for. It can also be known as something called convenience sampling. So this is something as simple as, let's say you need to figure out, what's the favorite food of people that people want to have. So then you might be like, okay, if you did other kinds of sampling, you might have to go through a long-winded process of finding a sampling frame. You might want to break them down to strata to find a more accurate representation. However, what you might just do is you might just go down to a nearest supermarket and ask the first 20 people that you see. And literally that is opportunity sampling. You literally just go down and meet the first few people who will fit your correct criteria that you want. You won't just ask some random person that you meet, but as long as they do fit the criteria, at the first opportunity that you meet them, you'll just ask them and you'll carry this on. So this is often quite a quick process that you have. So just like we looked for the random sampling, for this type of non-random sampling, we'll take a look at some of the advantages and the disadvantages. So for quota sampling, what happens is often a small sample can still be quite representative of the population sometimes, and that's because you've broken it into separate quota that you wanted to fill. And also you have no sampling frame. What this means is that you don't have to have a bunch of people to choose from. You can just keep asking people, and if they don't fit in your quota, then you don't count them. And if they do, then you put them in and you keep going until you finish. So you can basically just keep asking people and judge whether they fit your quota or not as you go along. So you don't need the sampling frame. So therefore, quota sampling can be quite quick and easy. You can decide if someone fits your quota or not. If they are, you can decide whether to put them in or not. So that usually works out quite nicely. And it can be quite easy to compare the different groups that you have in your population. So the different quotas that you have, you can kind of compare these two. But the problem is that obviously it's one of the non-random ways of doing stuff. So it does introduce some bias into it. So the bias can be down to the kind of quota that you choose, and the quota you choose can affect the final outcome that you get. And also you have to actually divide your population into the groups, and that means, just like stratified sampling in a way, trying to come up with these groups can be quite difficult. And finally, you don't actually record non-responses, because what I mean by this is if someone comes along and they do not fit in your quota, then you just discard them and just go on to the next one. You don't really make a record that this person didn't fit anywhere, and that doesn't really come into any of your sampling. So apart from that, we also have opportunity sampling, which is a lot simpler. So opportunity sampling is quite simple and quite cheap. That's the main advantages for it. Just going outside and just asking the first few people that you see can be very quick. But the problem is that if you do this, your sample's probably not going to be very representative, and it really depends on the researcher who's doing this. If I was doing this and I went down to my local supermarket, let's say someone else did this and went down to their local supermarket, it can really vary the results that they get depending on the kinds of people that they go to and who they see first. So while it is quick and easy, it's not always the best way to do things. So for our final part of the video, we're going to take a look at the different types of data that we have to deal with. So the first of these is quantitative data, and this is the kind of data that you can give a number to. So things like weight, things like your height, things like shoe size, all these different things can be given a number to. So you can be 160 centimeters tall, or you might be 50 kilograms in weight. So anything that can be given a number to is a quantitative variable in nature. So that's all it means to be quantitative, something that you can give a number to. You can give age a number, you can give shoe size a number, any of that kind of stuff. Next, we have qualitative kind of data. And this is basically something which you can't give a number to, something which is non-numeric. And things which fall under the category of being qualitative include things like color, things like emotion. So I might say that these flowers are red, this one's blue, this one's green, and I might take that down in a survey. But that kind of data which I've just recorded, that doesn't have any numbers involved. So that's why it's qualitative data. So basically the difference between quantitative and qualitative data is basically whether there's a number involved or not. So it's as simple as that. Then after that, we have two other types of variables. These are continuous variables and discrete variables. And these can only be the cases for usually the numbers that we have. So for example, in a continuous kind of variable, that can take any value. So what I mean by that is I could have run the race in 1 second, in 1.1 seconds, in 1.11 seconds, and so on. Or my weight might be 5 kilograms, it might be 5.2 kilograms, 5.25 kilograms, I could go on and on. So a continuous variable is anything that will take any kind of time in between it. So it doesn't really matter what value it takes, it can take any value in between a time period. So then we have discrete variables, and discrete variables can only take specific values. For example, if someone asks you how many children you have, well, you can't have 3.5 kids, can you? You can only have 3 kids or 4 kids. So this is an example of something which is known as a discrete variable, some kind of variable that can only be considered as a whole number. So that would be one example for it. So that's basically all the different types of data. We've got quantitative, qualitative, and then under the quantitative numbers, we've got continuous and discrete numbers. So that's more or less the differences between them. So if I go down now, we also have something known as group data. And you'll often see this in your frequency tables. And to be honest, there's not too much you really need to know about this that you don't already know. In fact, you'd probably know all of it. So we have things like class boundaries, the class width, and the midpoint. So class boundaries, as you can imagine, will tell you the largest and the smallest numbers inside your table. So if you take a look at this example here that we have, if we want to know our class boundaries, well, here we can see the class boundaries are between 110 and 120. This one here is your minimum value, and this one here is a maximum value. So these are your class boundaries. After that we have a class width. So this is telling you how far apart these are. So in this case, we can see that the distance between these two is 10. So we can see the class width is going to be 10. And finally, we have the midpoint. So how do we find the midpoint of a table? Well, this one's pretty easy. We have 110 to 120. So the midpoint we can easily find as being 115. So that's all you really need to know about group data, and that's how you put it in. So putting all of this together, we essentially have all of the different types of data which we need to understand for this chapter. And along with the other types of sampling, if you put it all together, it should really come together. And this chapter, yeah, it's more or less pretty simple. There's not too many questions in terms of numeric kind of calculations. Like a lot of your other chapters, you have to do a lot of calculations and whatnot. But in this chapter, a lot of it really is understanding the words and the meanings behind it. So the best way to revise the chapter at the end really would be to go through all the definitions, make sure you can remember them. If someone asks you what it is, make sure you can give a good explanation and some examples for each of them. And apart from that, just make sure you remember the advantages and the disadvantages of the different types of sampling. And normally a question will ask you, okay, I've done this kind of sampling, is it better than this one or is it better than this one? And the only real calculations you often have to do might be, can you give an example of how you do stratified sampling? How can you break it down and pick the right proportions from different groups? But overall, I hope this video has given you a good understanding of the basics of statistics. And if you really do understand this video well, it will give you a good base from which to do the next chapters. So I hope this video has been helpful for you, and